Alright. So question 3, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z, which equals 1.358, and to the left of z, which equals 1.358. Round your answer to 3 decimal places.
I got 0.175.
Okay.
That's assuming I used the applet correctly.
Because down at the z-score, you just typed 1.358, right?
Correct. Yep.
58. And what did you say you got?
Let me go back. 0.175.
Perfect.
It was, yeah, 0.1745 and just rounded up.
Yeah.
Okay.
So you just take the z-score. You put it down here, and then highlight what it tells you.
Yeah.
This period. Okay, question 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Are we able to figure that? Hey, get down! Are we able to figure that out?
It's a good question. That's what I'm trying to refresh myself here.
Observations are randomly drawn. I don't think we have enough information. Because wouldn't you need at least like one other number? Yeah, we don't know the standard deviation because we don't know the mean.
Right.
So it has to be the last one. Okay, 5. Which of the following results implies that the spread in X decreases as the sample size increases?
All right. That is. I get them confused. It's either the law of large numbers or the central limit.
And I can't remember what the central limit theorem is. Do you remember that?
Okay, let me go back and look at the question again. Increases and the sample size.
What is it called?
Central limit theorem. It's not in there.
Or was it?
Probably in 6. I just meant for you to Google it, but that works.
What kills me is the stupid little symbols. I can never remember what they mean.
I know.
Would you stop?
X with the line is the normal.
I think that's there, right? Is there really?
Yeah.
I'm back, guys.
All right, cool.
Uh,
We're down at like number 5. Did you get 3, 4?
Say that again?
Did you get 3 and 4? We're on number 5 at the moment.
No, I didn't get 3 or 4.
All right, for 3, it looked like it came out to 0.1745, so it's rounded up to 0.175.
Okay.
And then for
And-
4, it would be the third radio button there, the bottom one.
Cool.
And I believe that for 5, and correct me if I'm wrong, but I believe that is the law of large numbers.
All right, that's cool. And the X with the line over it, what did that mean again? I remember seeing that.
That is, let me make sure I'm looking at this right.
The sample.
The sample distribution of X will be normal, so let's see, that's not the right one. I hate those stupid symbols.
Right.
Sample distribution?
Yeah. Yeah. So which of the following results implies that the spread in sample distribution decreases as sample size increases? Stop. Okay.
All right, so
How many questions? It's 15.
I feel like it's just normal distribution.
What is the Z-score?
What?
Wait, are you guys on number 6?
No, we're on 5.
5.
Oh, still on number 5. Oh.
Would that make sense, or am I just pulling that out of the air? Can I see? Go.
Sample gets smaller. Central limit states that the sample size is large.
That didn't answer any questions.
Central limit theorem. If I'm looking over the
So it's
chapter 6.
Because if it decreases, the sample size increases. Isn't the sample size? Isn't that you? Whatever you.
It's the mean.
Oh, so this isn't the
Well, hang on.
standard.
Maybe it is the law of large numbers. Because I'm looking. Is this from lesson 6?
Yeah.
Because I'm looking in the notes from lesson 6, and it says if the standard deviation of the sample mean gets smaller, what happens to the value of x? And it says the values that will be observed will be very close to each other and therefore close to the mean if the sample size is large.
Okay. Well, that's what I thought initially, but
Yeah.
you got me question it.
I know.
All
Sorry. That was my fault.
right. I'm not overly confident with this material, obviously.
I don't think any of us really are. Except for Jordan, maybe.
What's that?
Nothing. Okay. So 6. Use following information. Okay. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Okay, so we just have to use this,
The formula.
yeah.
And unfortunately, I'm on my work computer, which makes none of this easy.
So it's just z equals value minus mean over the standard deviation.
Yeah. Okay.
Equals. Okay. Do you have a calculator?
No, but I can get one if you want.
I might need it. Just go away. Go away. Go.
She wants attention.
I know. So I got 1.045.
Still working on it here.
You're good. Hmm?
I'm supposed to round it.
But it would still be 1.045 because it's repeating. What do you need? What?
Go aside.
Hmm? Jordan, did you come up with anything yet?
Not quite. No, I'm sorry. I'm trying to finish this one thing up. I'm gonna be with you guys in just a second.
Okay, you're good.
I'm sorry, and you got, what was it again you got?
I don't know. Let me pull it up again. 1.045?
Yep, okay.
Okay,
That's where I'm at.
sweet. Okay, what is the probability that a randomly selected student will score above a 160 on the quantitative portion? So would you just put the z-score in the applet?
Sounds like that's what.
Okay. So we put 1.045.
0.296.
Would you shade both areas on either side or the one in the middle and the right side?
That's a good point. Let's look.
Because it says score above a 160. So would
You're
you
right.
do-
You're right.
So would it be 0.85?
8520. So
852. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean? No cramp. Okay, so just find the mean. 160 plus 175 plus 163 plus 149 plus 153 divided by 5 is 160. Okay, so we have the mean. And I'm guessing we just use that same formula, right?
Yeah, I'm not really sure yet. I'm still trying to get everything calculated here.
Okay. Okay, so okay, just so you guys know, I have another group meeting in a half hour that I can't be late to, so I may have to, if we're not done by then, I may have to leave early.
So hopefully we'll be done by then. I mean, we're on number 8, so.
Yeah. Okay.
What?
Nothing.
And what did you say your z-score came out to be?
I haven't yet.
Okay.
Lee, what did you put for the value?
It's not bad. I'll get you later, dude.
I'm working on it. Give me a second here.
Okay. Because the mean is 160, and then the standard deviation from the previous information is 8.8. But I don't know what the value would be.
Which number are you guys on right now? 8?
Yeah.
Okay. Do we know what the standard deviation is?
8.8.
Yeah, 8.8.
Wasn't z-score just the sample minus the mean over the deviation?
It's the value minus the mean over the deviation.
Yeah. What is the z-score square amounting to the sample of the student's scores? Well, how do you know? What's the value? Like, what's the...
That's what I don't know.
Okay, would it not just be the 160, the mean?
As the value?
Right.
I don't think so. Because then you'd be subtracting 160 by itself and then dividing by 8.8, and that's 0.
Why would they give us this without an actual value?
I have no idea.
I think it's just supposed to be 160 from number 7, right? Or no, I don't.
I don't know. Would it be the same as? No, it wouldn't. Well, actually, would it be the same as number 7?
That's what I was just looking at. Is like it looks like they keep mentioning 160 and 160.
Right.
Just asking because earlier we were finding out with given 150.8 as the mean. So now they're just changing the mean on us. So
right.
160 minus. Oh, what did this mean end up being? 800 divided by 5. So 160. Yeah. Well,
it is. It's 0.852.
Well, how do you do? Wait a second.
Because 160 minus 160, it's 1.
Yeah, that's. And 0 divided by anything is 0. So I guess it'd be 0. That's going to be my guess.
Okay.
Yeah, because 0 divided by anything is 0.
Okay, so what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So I don't think it's 0.
We'll have a mean score that is greater than the mean achieved. So don't we use the applet right now?
Yeah.
And it's just 0.5, 50%. Then because if it's 0, that's dead on in the middle.
So it's
to 4 decimal places? What's the point? See, that makes me feel like we got it wrong.
Yeah, me too. Because in the example, it has a 0 in front of every number. And if you put in the applet 0.5, the area is 0.6915.
Wait, say that again?
So in the example, it says if the answer is 0.09281, but when I put it in the applet, we put 0.5 as the z-score, and then I shaded the middle and the one to the right, and the area is 0.695.
You put the z-score as 0?
0.5.
Well, the area is supposed to be 0.5. That's the probability. The z-score, I think, is 0 because there's 160 minus 160 in number 8. I can turn in mine first. We can try it out.
Okay.
All right.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected?
Okay, so suppose I zoned out there for a second. All right, so the mean is 3.5. Standard deviation is 0.7. Is one distributed left skewed to random. We haven't had a test in this class yet, have we?
No, that's next.
Oh, is it really?
Yeah.
I'm gonna fail it.
Who wants to take that with me? All right. So a random sample of n equals 81 students will be drawn. So 81, and then what is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students or so? I don't understand this whole skewed thing.
Yeah, I don't really get it either.
I think I wrote it down. Hang on. Okay.
Okay.
Okay, so z-score is x with the line over it, which is the sample mean, right? Minus the, what's the U stand for again?
Mean.
Oh, okay. Minus the mean. So all on over the standard deviation, and that is divided by the square root of something. I don't know what you call it.
So it'd be 81, the square root of 81 divided by 0.7.
I think the 81 would go on the denominator.
Yeah.
So it'd be well, we're not given a. I don't think we have enough information because we're missing x. We're missing one variable for this.
Right.
We don't need it.
Or would x be the GPA? Or just kidding, that's the mean. Never mind. Scratch that.
Okay, so the mean is 3.5. So that's sample mean, which we're not given, minus 3.5 all on over standard deviation of 0.7 divided by square root of 81.
Wait, did you just say we weren't given the sample mean?
I don't think I think we're missing one variable. Well, at least in the notes, like it talks about how yeah, everyone uses two numbers on the denominator. It's just like the mean of the, okay, so
Because on the denominator, it would be 0.7 and the square root of 81. I think we're missing
right, yeah, on the top one, that x.
the value. That's the random variable. So I don't think we have enough information.
I don't think so either, because I mean we're only given, like you were saying, like 3 variables, but it looks like we need 4.
Right.
So I mean I can guess that one again. All right, so what is the mean of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? What is the mean of the distribution of the sample means? What? For all possible samples of size 81 that could be drawn from the parent population. I don't even understand that. Is that English? What is this?
Yeah.
What is the mean of the distribution of the sample means? What? What?
Okay, so what is the mean of the distribution of the sampling distribution?
You want to explain that, Sarah?
No, because I don't know what that is. For all possible samples of size 81.
Maybe we can't. Ouch.
I have no idea.
What is the mean of the distribution of the sample means? Sampling distribution. Okay, let me look this up. Sampling. Okay, so the sampling distribution is that X.
Right. So now we have to find the variable we were missing, right?
One
But
second.
it asks for the mean. What?
Okay.
No, I kind of wish that TA would be here.
No
Mhm.
kidding.
So if it's asking for the mean, would it just be
But
3
what are the sample means? I guess 3.5. Can you do just sample X equal?
I don't know, because look at the next question. It asks for the standard deviation of the same question. So would the standard deviation be 0.7?
Solve for X. The standard deviation of the random variable is a sample mean is equal to the mean over the square root of n. Okay. Okay, so we have mean, which is 3.5 divided by square root of n81. So 3.5 divided by 9. And that equals 0.3889. So is that what X is? I think it might be, because it says right in here, for the mean of draws from a random variable with mean U and a standard deviation O, the following are true. The standard deviation of the random variable X with a line is, the mean of the random variable, what? How can that equal two different things? Come on. Okay, wait, the O means what again?
That's the standard dev.
Oh, that's standard 7 divided by 9. And that is 0.0778. If we're rounding it to 4. Okay, and then, so standard deviation of the random variable is 0.0778.
Okay.
And then the mean of the random variable
Good question.
is equal to U, which is just 3.5, right?
Mm-hmm.
Correct. Yeah.
So when we wait, how can X be both of those? My question. Okay, so what is X down here in this equation?
See, that's the thing. I don't know.
Oh, boy.
Oh, wait.
Are you in 11 or 12?
X would be 81, right? Because it says find the distribution of sample means for all possible samples of size 81.
I think that's our best guess so far, yeah.
Because it's saying that the sample size is 81.
Mm-hmm.
Excuse me.
Random variable X.
All right.
Okay, yeah, so the mean of the random variable X is U. So for all possible samples of size 81 that could be drawn. Oh my gosh, this is not easy at all. I don't feel like the notes give enough info for this either.
No, I agree. This is the most useless textbook I've seen yet. I mean, genuinely, I would much rather just pay $100 for an actual paper textbook.
I agree.
I feel like it's just repeating itself and then adding in one word, but not really going. The
Yeah.
mean of the normally distributed random variable insanity, what is probably will have a value that is less than negative 25. Is it asking for a value of something? It's saying samples of size 81 that could be drawn from the parent population. But that's not saying if it's, okay, it's just 81. I don't understand that because all the other ones are like 20,000 or less or something.
Right.
You know, and this one's just straight up 81. That's not. Did I like open a different one? No. Well, the parent population is normally distributed, it says.
All right. Um, any ideas, anybody?
I just don't even understand the question yet. Let me see.
Yeah.
Oh, come on. It says I have one email in my inbox, but it's not showing me what it is. I hope it's the TA.
No kidding.
Okay, well then show me what's on red. This is. Oh, no, this is from January. I don't know. I think we should just move on. I don't understand it.
I agree, because I gotta go in like 5 minutes.
All right, let's try number 12. What is the standard deviation of the distribution of the sample means? Wait just a second. I'm going to try something real quick.
It's probably
You guys can move on. I'm going to try to find this one real quick.
What is the probability?
Let's see. Do you have the area?
No, that's what I'm supposed to find.
What do you have?
I have the mean, standard deviation, and yeah, I'm missing X.
But you have the z-score?
No.
You need,
I know I need X.
or you need the z-score.
Oh.
You go.
Okay, guys, here's something I just noticed, though. In step 5 in here, it says that there are two cases when X with the line is guaranteed to be normally distributed, and they are the parent population is normally distributed, or the central limit theorem guarantees the distribution of X is normal if the sample size n is large enough. For this course, we require n to be greater than or equal to 30. Does that make sense? So on question 10, if the sample mean n is greater than 30, it would be normal.
It would be right skewed.
Well, it says it guarantees the distribution of X is normal if the sample size n is large enough. So require n is greater than or equal to 30. So I'm not totally sure how to interpret that, but it sounds to me like question 10 would be approximately normal.
Okay.
Because n is 81.
Right.
And then I'm going to keep reading along with that, see if that gives us a little bit more.
All right.
The standard, okay. What? The collection of all possible sample means. Okay, yeah. This one I think is talking about it in step 5. Ouch. Get my leg. And ow. And okay, so the standard deviation for the distribution of sample means is that O over square root of n. And which one was that? That one was O is, gosh dang it, why can't I remember 3 variables?
O is the standard deviation. That's the only one I can remember.
Okay, good. All right, so standard deviation, so that one was 0.7, so that one is the 0.0778. So I think that's X, or that's when it's talking below, what is the mean of the distribution of the sample means? Well, the sample means is supposed to be that O over n. The parent population standard deviation, and n is the sample size. Once we have determined that the sample mean is normally distributed, we can compute probabilities with x. We first compute, so we have the mean of the distribution of the sample. I don't get it, because it talks about x and then it talks about u, and then it just gives you this equation, but it doesn't tell you which one it is really. But it says the collection of all possible sample means x is O over square root of n. So I'm just going to put that down, 0.0778. So we don't have much time, and that's my best guess.
And you're
On
on
11?
Yeah, 0.0778. And what is the standard deviation for the distribution of sample means for all possible? What I think. What is this of the distribution?
Don't rush, you guys. It's okay. I can leave, and my husband's group is doing this at 9:30, so I can do it with them too. So don't rush because of me.
Okay.
So
All
you're
right, well,
fine.
Why don't we? I don't think we need to meet again, but we could just do something over the group text, and
Yeah.
if we have anything or find anything, is that going to be too late for you, Lee?
No. Let's just knock it out.
That's going to be like 11 o'clock your time, I think, by the time they're done. Or later.
No, but I mean, we can go ahead and you and I can just keep working on this.
Yeah.
All right, yeah, we can try that.
Okay, I'm going to have to stop the broadcast, so if you guys want to start another one, you can, but I have to stop it since I'm the one that started it.
All right, can you
You can just mute your mic.
text me tonight, Sarah, if they get any answers that are different?
Yeah.
Cool, because I'm going to save my second submission for that, if that's okay with you.
Cool.
All right, and then, all right, well, if you got to go, Sarah, that's all right. I'm really not understanding this, though. It's really throwing me off here.
All right. So
What is the standard deviation of the distribution of the sample means?
Okay, so I'll text you guys if they get anything different.
All right,
Okay.
good.
Okay, see ya.
I'll just send you a text, Sarah, if we get any of these right. Or
Okay,
we'll submit it too.
sounds good.
Whatever. Yeah, we'll figure it out. All right, we'll see you later, Sarah.
Bye.
Thanks for meeting.
take it
Bye.
easy.